Hello students. Today let us revise the topic ICT in UGC NET Paper 1. ICT. Information and Communication Technology, often known as ICT, is an umbrella term that includes any communication device or application encompassing radio, television, cellular phones, computer, and network hardware and software, satellite systems, and so on, as well as the various services and applications associated with them, such as video conferencing and distance learning. Information and communication technologies are playing an increasingly important role in India's higher education system. ICTs are being used to improve teaching and learning, enhance research, and streamline administration. Some of the ways in which ICTs are being used in India's higher education system include online learning, blended learning, e learning resources, communication and collaboration tools, research tools, and administrative tasks. Online learning. ICTs are being used to deliver online courses and programs which make education more accessible and flexible for students. Many Indian universities and colleges now offer online degrees and courses, and there are also a number of dedicated online education providers. Blended learning. Blended learning combines traditional face to face teaching with online learning activities. This approach can help improve student engagement and learning outcomes. E learning resources. ICTs are being used to create and deliver a wide range of e learning resources such as interactive tutorials, simulations, and assessments. These resources can help students to learn at their own pace and in their own way. Communication and collaboration tools. ICTs are being used to facilitate communication and collaboration between students, instructors, and researchers. This can be done through email, discussion forums, video conferencing, and other online tools. Research tools. ICTs are being used to support research in a variety of ways. For example, researchers can use ICTs to access online database, conduct surveys, and collaborate with colleagues around the world. Administrative tasks. ICTs are also being used to streamline administrative tasks such as student registration, fee payment, and exam results. This can free up staff time to focus on teaching and research. Major learning categories using ICT. Information and communication technology encompasses a wide range of learning categories that cover various aspects of technology and its application. Some major ICT learning categories in education are as follows. E-learning. E-learning or electronic learning is an educational method that uses digital technology and the internet to deliver instructional content and facilitate learning experience. It allows learners to access educational materials remotely, often at their own pace, through online courses, webinars, and other digital sources. Blended learning. Blended learning is an educational approach that combines traditional face to face instruction with online and digital learning methods. It integrates classroom teaching with virtual components, enabling students to access resources, engage in activities, and collaborate online, fostering a flexible and personalized learning experience. Distance learning. Distance learning, often called remote learning, is an educational method where students access instruction and course materials from remote locations, typically via the internet. It allows for flexible learning schedules and is utilized in formal education, professional development, and continuing education, including instances like pandemic related school closures. Face to face learning. Face to face learning, often referred to as traditional classroom instruction, is an educational approach where students and instructors physically meet in a designated location for an in person teaching, discussions, and interactive learning experiences. Self paced learning. Self paced learning is an educational method that allows individuals to set their own learning pace and progress through course materials independently. It provides flexibility in terms of when and how quickly one completes the learning objectives. Digital initiatives in higher education. Department of Higher Education, Ministry of Human Resource Development is administering a program, National Mission on Education through Information and Communication Technology, also known as NMEICT, to leverage the potential of ICT to make the best quality content accessible to all learners in the country free of cost. The various initiatives under this program are Swayam, study webs of active learning for young aspiring minds; The Study Webs of Active Learning for Young Aspiring Minds is an integrated platform for offering online courses covering school 9 to 12th to postgraduate level. SWAYAM is a program initiated by Government of India and is designed to achieve the three cardinal principles of education policy, which are access, equity, and quality. The objective of this effort is to take the best teaching learning resources to all, including the most disadvantaged. SWAYAM seeks to bridge the digital divide for students who have hitherto remained untouched by the digital revolution and have not been able to join the mainstream of the knowledge economy. Second, Swayam Prabha, the 80 educational DTH channels. The Swayam Prabha has been conceived as the project for telecasting high quality educational programs through 80 DTH channels on 24/7 basis. Every day, there will be new content of at least 4 hours, which would be repeated 6 times a day, allowing the student to choose the time of his convenience. The project was conceived and completed within 3 months with the active participation of the Bhaskaracharya Satellite Application Center and Geoinformatics, Gandhinagar, and ECIL, Hyderabad. Third, National Digital Library, a project titled Development of National Digital Library of India towards building a national asset has been sanctioned to IIT Kharagpur under NMEICT by MHRD. National Digital Library in India aims to collect, preserve, and disseminate entire intellectual output of our country and provide online access from school level to postgraduate level, including technical education. Project aims overall framework to collate large numbers of e-contents for schools, colleges, and higher education. E-content virtual library covering needs of learners with differing abilities. Design and development of OAI PMH server for metadata harvesting, indexing, etc. Service Pan India virtual teaching, learning, evaluation, knowledge platform for the key national asset and collect resources from other ministries such as Ministry of Culture, Health, Rural Development, and Department of Science and Technology on this portal. National Academic Depository NAD. National Academic Depository is an initiative of Ministry of Human Resources Development, Government of India to facilitate digital issuance, storage, access and verification of academic awards issued by academic institutions. NAD is a unique, innovative and progressive initiative under Digital India theme towards achieving digital enablement of the education records. E-Shodh Sindhu. Based on the recommendation of an expert committee, the MHRD has formed eShodh Sindhu, merging three initiatives, namely UGC InfoNet Digital Library, Enlist, and Indeset AICTE. The eShodh Sindhu will continue to provide current as well as archival access to more than 15,000 crore and peer-reviewed journals and a number of bibliographic, citation, and factual databases in different disciplines from a large number of publishers and aggregators to its member institutions, including centrally funded technical institutions, universities, and colleges that are covered under 12B and 2F sections of the UGC Act. This allows access to be best education resources in the world using digital mode. Virtual labs. Physical distances and the lack of resources make us unable to perform experiments, especially when they involve sophisticated instruments. Also, good teachers are always a scarce resource. Web based and video based courses address the issue of teaching to some extent. Conducting joint experiments by two participating institutions and also sharing costly resources has always been a challenge. Web enabled experiments can be designed for remote operation and viewing so as to enthuse the curiosity and innovation into students. This would help in learning basic and advanced concepts through remote experimentation. Internet based experimentation further permits use of resources, knowledge, software, and data available on web, apart from encouraging skillful experiments being simultaneously performed at various points in space and possibly time. Virtual lab does not require any additional infrastructural setup for conducting experiments at user premises. One computer terminal with broadband internet connectivity is all that is needed to perform the experiments remotely. E-Yantra. An MHRD initiative named E-Yantra is implemented to incorporate robotics into engineering education with the objective of engaging students through exciting hands-on application of mathematics, computer science, and engineering principles. Creation of robotic platforms has been very successfully demonstrated during phase 1 of the project. Presently, eYantra has been implemented in 100 colleges. eYantra is creating skills by setting up lab infrastructure for project-based learning and training teachers in these 100 engineering colleges. All the projects and code are available on the eYantra website www.eyantra.org as open resource content. eAcharya eAcharya, also called Integrated E-Content Portal of NMEICT, is the official repository e-content and all content produced under it. It is being put at this repository platform at the center in Gandhinagar. So, to apply basic tenets of preservation for digital content, implement standard metadata schema of different types of digital content, and ensure their long-term availability. eKalpa, another MHRD initiative named eKalpa, creating digital learning environment for design in India, has successfully demonstrated the achievement of the following project objectives on completion of its phase 1. Digital online content for learning design with e-learning programs on design. Digital design resource database including the craft sector. Social networking for higher learning with collaborative learning space for design. Memory hierarchy. Computer memory is an essential component of a computer system used to store and retrieve data and instructions for processing. There are several types of computer memory, each serving different purposes and having varying characteristics. Here are the various types of computer memory. First is primary memory or the main memory. RAM. RAM is volatile memory used for temporarily storing data that the computer is currently processing. It allows for fast data access and retrieval, but loses data when the computer is powered off. Secondary memory, also called storage memory. Hard disk drives. HDDs are non volatile storage devices that store data on magnetic disks. They provide high capacity storage but have slower access time compared to RAM. Solid state drive (SSD). SSDs are non volatile storage devices that use NAND flash memories. They are faster than HDDs, consume less power, and have no moving parts. Optical drives CD, DVD, Blu ray. Optical drives read and write data to optical disks. They are commonly used for data backup, software installation, and media playback. USB flash drives. These portable, non volatile storage devices use flash memory and connect computers via USB ports. They are used for data transfers and backups. Memory cards. Memory cards are small, removable storage devices used in cameras, smartphones, and other devices to store data and media files. Cache memory. L1 cache. L1 cache is small, high speed memory integrated directly into the CPU. It stores frequently accessed data and instructions for quick access. L2 cache is larger but slightly slower cache memory and also resides close to the CPU. L3 cache. Some CPUs have an additional layer of cache memory called L3 cache, which is larger but slower than L2. Virtual memory. Virtual memory is a memory management technique that uses a portion of the secondary storage, usually the hard drive, as an extension of RAM. It allows the computer to run larger programs and manage the memory more efficiently. Read only memory. BIOS ROM. The basic input output system is a firmware stored in ROM that initializes hardware during system startup. EPROM and double EPROM. Erasable programmable read only memory and electrically erasable programmable read only memory are types of ROM that can be programmed and reprogrammed, allowing for updates to firmware. Flash memory. Flash memory is a type of non volatile memory used in USB drives, SSDs, memory cards, and other storage devices. It can be electronically erased and rewritten, making it suitable for data storage. Registered memory. Registered memory is the fastest and smallest type of memory in a CPU. It is used to store data temporarily during CPU operations. Network memory. Network memory refers to the memory sources used in distributed computing and network environments where data is stored across multiple interconnected computers. Types of computer network. Computer networks come in various types, each designed to serve specific purposes and meet different needs. Here are some common types of computer networks. LAN. A LAN connects devices within a limited geographic area, such as home, office, or campus. High data transfer rates and typically used for sharing resources like files, printers, and internet access among nearby devices. Wide area network WAN. WANs cover a larger geographical area and often connect LANs across cities, states, and even countries. It utilizes public and private infrastructure such as the internet to enable long distance communication. Metropolitan area network MAN. MANs are intermediate in size between LANs and WANs, usually spanning a city or a large campus. commonly used to connect multiple LANs in a metropolitan area. PAN, Personal Area Network. PANs are small networks designed for personal devices with a short range, typically within a few meters. Examples include Bluetooth connections between smartphones and peripherals. Campus Area Network, CAN. CANs interconnect multiple LANs within a university campus or corporate campus, designed to provide high speed and reliable communication among various departments or buildings. Storage Area Network, SAN. SANs are specialized networks dedicated to storage devices like disk arrays and tape libraries. It provides fast and scalable storage access for servers and applications. Wireless Local Area Network. Wireless Local Area Network use wireless technology such as Wi-Fi to create a local network without physical cables. Common in homes, offices, and public places for wireless internet access. Virtual Private Network (VPN). VPNs create secure, encrypted connections over public networks, used to establish private communication channels for remote access, data protection, and secure connection between geographically distant locations. Peer-to-peer network. Peer-to-peer network allow devices to communicate and share resources directly with one another without a central server. They are commonly used for file sharing and collaborative applications. Client server network. In a client server network, client devices such as computer or smartphones request services or resources from central servers. Widely used for web browsing, email, and database management. Internet of Things network. IoT networks connect various smart devices and sensors, enabling data collection, analysis, and control of interconnected objects. Key for applications in smartphones, cities, and industrial automation. Intranet and extranet. Intranet are private networks used within organizations to share information and resources. Extranets extend this concept to include trusted external parties such as partners or clients while maintaining security. Web 3.2. Web 3.0 represents the next phase of Internet characterized by decentralization and built on blockchain technology. It distinguishes itself from its predecessors, Web 1.0 and Web 2.0, by enabling users to have an ownership stake in platforms and applications, challenging the dominance of tech giants. Gavin Wood, the founder of Ethereum, a blockchain technology company, first introduced the term Web 3.0 in 2014. Over the years, many others have contributed to the development and conceptualization of Web 3.0. Let us talk about the various components of Web 3.0. First is semantic data. Web 3.0 is designed to understand and interpret data more intelligently. It involves the use of metadata, ontologies, and structured data to provide context and meaning to information on the web. This enables better search results, data integration, and automated reasoning. Decentralization. One of the key components of Web 3.0 is the move away from central authorities and platforms. It aims to enable peer to peer interactions, reducing reliance on intermediaries and increasing user control over the data. Blockchain technology. Web 3.0 leverages blockchain and distributed ledger technology to ensure data integrity, security, and transparency. Blockchain is used to verify and record transactions, making it resistant to fraud and tampering. Linked data. The concept of linked data involves creating links between datasets on the web, making it easier for machines to understand the relationships between different pieces of information. This fosters interoperability and seamless data sharing. Artificial intelligence. AI plays a significant role in Web 3.0 by enabling the development of intelligent agents that can understand and respond to user queries in a more human like way. AI driven chatbots and virtual assistants and recommendation engines are examples of this. Natural language processing. NLP technology allows computers to understand and generate human language. In Web 3.0, NLP enables better human computer interaction and more intuitive user experiences. Machine learning. Machine learning algorithms are used to process and analyze vast amounts of data, making the web smarter and more adaptive. They can detect patterns, provide personalized content, and improve search results. Personalization. Web 3.0 is expected to provide highly personalized experience where content and services are tailored to individual user preferences and needs. Privacy and security. With the increasing focus on data privacy, Web 3.0 emphasizes user control over their data and privacy settings. It incorporates encryption and security protocols to protect user information. Interoperability. Web 3.0 aims to create a more seamless and connected digital environment where different devices, platforms, and services can communicate with each other effortlessly. This enhances the Internet of Things and cross platform functionality. Open standards. The use of open standard and protocols is encouraged in Web 3.0 to ensure the data and applications are not tied to a specific proprietary platform. This promotes accessibility and reduces vendor lock-in. Data ownership. In Web 3.0, users have greater control over their data and can specify how and where the data is used. Data ownership and consent are essential principles. That's it for today's video. We wish you all the very best for the upcoming exam.